Good day everyone! Today I am going to present to you my mathematical investigation entitled Factorization of Large Composite Numbers Using Fermat's Method, presented by yours truly, Miss Althea May K. Nano. So to start off, let's go to the introduction part. Many problems in number theory require factorization of some given integer. The only efficient factorization method is by the use of factor trees and factor tables. But unfortunately, it is not possible to include all of the integers in these methods. Consequently, we must rely on other less efficient method. And the most obvious technique is to divide the primes less than square root of n into n and see which if any leave no remainder. This work well if n is small, but according to James E. Shackley, the author of the book of Introduction of Number Theory, that it is not possible to include all of the integers in the table. This observation leads the question on how to factor large numbers. In this study, Fermat's method of factorization is used to investigate this problem. Results of their investigation were published in Chapter 8 in the book of Introduction of Number Theory by James E. Shackley. This study was based in the book. As an expansion on James E. Shackley's work, this paper discusses and provides proof of some theorems. It also provides additional proofs of theorems which were not provided in the book. Next is the statement of the problem. This paper presents an expanded elucidated in Chapter 8 in the book of Shackley entitled Factorization of Fermat's Method. It contains proof on the investigation on how to factor large numbers by using Fermat's method. Specifically, this paper tends to answer the following questions. First is, given n is a difference of two squares where n is an odd integer. N is greater than 1 is a non-prime if and only if there are non-negative integer p and q. Can we find integers p and q where n is equal to p squared minus q squared, or equivalently such that p squared is equal to n plus q squared, or q squared is equal to p squared minus n? Secondly, given p squared is equal to n plus q squared as the equation, is it possible if we let q is equal to 1, 2, 3, and so on and so forth until n plus q squared is a perfect square or not a perfect square? Third, given n as large odd integer, where n is the difference of two squares, can we factor n using the equation p squared is equal to n plus q squared?
So now let's proceed to the investigation, which is showing data of specific examples. So we have here letter A, assuming that 72 is a prime number. By using the equation, p squared is equal to n plus q squared, and let q is equal to 1, 2, 3, and so on and so forth until n minus 1 divided by 2. So, last time I presented my mathematical investigation and then stuck ko sa example na ko sa number 72 because I cannot support my answer because Ma'am or Dr. Normina Batukan said to me that I am going to use 72 as one of my examples, and then I will gonna apply the Fermat's method. So here it is. So here is the solution. So as you can see in the PowerPoint, we have this letter Q and we have this n plus q squared. So asa man nato ni siya gikuha? So ato ni siya gikuha sa given nga equation nga naa dinhi sa taas, which is kaning by using the equation p squared is equal to n plus q squared. Okay? So, our q kay kaning 1, 2, and 3. And then, if we are going to substitute the values using the equation that is being given, which is the p squared is equal to n plus q squared. So, kaning nga side, din sa pika side, ang equation nga to ang gigamit ani is kaning n plus q squared. So, we will gonna substitute. So, since our n here is 72, that's why we have 72 here. And then, we have 1, which is our q. That's why ang pinakaunang number din sa q is 1. So, we have 1. Since it is squared, so we have 1 squared. So, 72 plus 1 squared is equal to 72. And, do you think that would be the answer? So, dili pa na siya mao ang answer because it is not a perfect square. So, unsa man natong buhaton if dili siya perfect square, we will gonna proceed to the next number. So, since manaman ta sa 1, so mo-proceed na po ta sa 2. So, ato na pong 2 karon or ang ato ang q rather is 2. So, we will substitute again 72 plus 2 because 2 ato ang q and then we will gonna squared. So, 2 squared. So, 72 plus 2 squared is equal to 76. 76 is not a perfect square, right? Diba? So, dili siya perfect square. So, proceed ta sa 3. So, atong q na po dire is 3 and then substitute 72 plus 3 squared. Same process. So, we have 81. And we all know that 81 is a perfect square. Perfect square siya sa 9 squared because 9 squared is equal to 81. So, 9 ang iyahong perfect square sa 81. Okay? So, mo na ang first step. So, maka-conclude na ta nga ang n nato is a composite number and its factors may be calculated by using the Fermat's method. So, ang Fermat's method is the two difference square. Diba? So, we have the formula of n is equal to p squared minus q squared. Okay? Or n is equal to q squared minus p squared. So, depende lang yun na siya. So, we have our n here, 72, is equal to unsa man ang ato ang q. Or, unsa ato ang p. So, ang ato ang p and dinhi is 9 squared. Diba? Kay mao man ay square root sa 81 ang 9. Pero, kinahanglan nato is squared kay squared man ang sa method na to, sa formula ni Fermat. Okay, so we have 9 squared minus kay difference man, so minus. So we have the q. Asa man ta ni stop? Sa 2 or sa 3? So sa 3 ta ni stop. Kay dinhi man na bilong pud ang ato ang p. Okay? So 3 man ato ang q, so we are going to square that one also. So we have this 72 is equal to 9 squared minus 3 squared. And the next step that we are going to do is to factor out 9 squared and 3 squared. So we have in 9 squared, we have 9 minus 3 and then 9 plus 3. Okay, so answer na siya mo. So, mo na siya factors nga ato ang na-calculate sa 9 squared minus 3 squared. So, na-factor out na nato. So, naanatay 9 minus 3 and 9 plus 3. So, if ato na siyang i-solve, magawas sa Japon ang 9 squared o 3 squared. Okay? So, ato na pong i-calculate ning 9 minus 3 is equal to 6. And then, 9 plus 3 is equal to 12. Do you think 6 and 12 is the final answer? So, dili pa na siya mao ang final answer, no? Because as we all know that we can still factor out 6 and 12. Okay? So, first, we are going to factor out 6. So, we have 3 and 2. So, we have here 3 times 2. Times factor out sa 12, 6 times 2. Okay? So, we will just copy 3 and 2 because dili naman nato na ma-factor, diba? So, we have 3 and 2 times ma-factor na to ang 6, right? So, ma-factor na to ang 6 ug 3 and 2. So, we have 3 times 2. Copy the remaining times 2 here. So, since na naman tayo 3 times 2 times 3 times 2 times 2. Okay? So, all we have to do na po dinhi is to count lang. I-count lang yun na to kung pila ka buok 3 ang naa dinhi o pila ka buok 2. So, that's why naatay 3 squared kay duwa raman ka buok 3 dinhi times 2 cube. Kay tulo ka buok 2 ang naa dinhi. So, 3 squared minus 2 cube is the factors of 72. Okay? And I realized that 72 is not a prime number. Okay? It is an even number. And remember that we are going to factor odd numbers only. Okay? Not an even number. But then, nakapangita rapod ko og way og unsaon siya by using also sa Fermat method. So yeah, na-answer na ko ang gihatag ni ma'am or ang akong gihatag nga example nga wala na ako nahatagan og support. So let's proceed to the next example. So we have here letter B. N is equal to 23 is a prime number. Let Q is equal to 1, 2, 3, and so on and so forth until n minus 1 divided by 2. By using the equation, P squared is equal to n plus Q squared. So we have here the solution. So same process nga ato ang gibuhat kanina sa example number 1 nato. So we have here our Q and the n plus Q squared. So the first number din sa atong Q is 1. So same process, substitute the values. So our n here is 23. So we have 23 plus 1 squared because Q squared man na. So we use 1 squared din hipod kay 1 man atong Q. So 23 plus 1 squared is equal to 24. So understood lang ha nga naay na squared din ha. So 24 is not yet a perfect square, right? So proceed ta sa 2. So 23 plus 4 is equal to 27, not a perfect square. 23 plus 9 is equal to 32, not a perfect square. 23 plus 16 is equal to 39, not a perfect square, up until dinhi sa ato ang Q nga 11. So we have here 23 plus 121 is equal to 144. And we observe that 124 is not a perfect square. And mag-ask na ta sa tong kaugalingon nga, if mo padayon pataan ni, can we still proceed? Or kinahanglan pa ba mo proceed? Remember this, let Q is equal to 1, 2, 3, 4, and so on and so forth until n minus 1 is equal, or n minus 1 divided by 2. So, ang pasabot aning n minus 1 divided by 2, dapat ang n na to, or ang ato ang Q rather, is dili siya pwede mo lapas. Dili siya mo lapas, pasabot, if ato ni siyang isubstitute ning n minus 1 divided by 2, so we have 23. 23 man atong n, no? So we have 23 minus 1 divided by 2. So we have 23 minus 1 is equal to 22 divided by 2 is equal to 11. That's why we are going to stop calculating sa ato ang Q sa number 11. Bahalag wala ta nakapangita sa iyang perfect square because that is a rule. Rule na siya. Okay? So, ni-stop ta sa 11 sa atong Q and ni-stop ta sa ato ang P squared po dinhi nga 144. And 144 is not a perfect square. That's why we conclude here that since we have not reached a perfect square before Q is equal to n minus 1 divided by 2, then n is a prime number which its factor is only the number itself and 1. Okay? But we are going to check that one. Okay? Ato i-check if equal ba. Okay? So, So, by using the Fermat method, which is n is equal to p squared minus q squared. So, our n here is 23. Is equal to, pila tong p squared? 12. 12 because, mo man ni ato 144. 12 times 12 is equal to 144. Minus 11, that one, 11 squared. So, i-factor out na to. So, we have 12 minus 11 and 12 plus 1. So, we are going to calculate that. So, 12 minus 11 is equal to 1. 12 plus 1 is equal to, 12 plus 11 is equal to 23. So, that's why ni, atong answer din hi is 23. So, ang factor sa ato ang n, which is ang 23, is 1 and the number itself. So, since ato ang number itself din hi is ato ang n din hi is 23, so 23 ug 1 ang factor sa ato ang n. Okay, gets ra? Okay, so let's proceed. So, let's proceed to the third example. So, we have here letter C, assuming that 527 is a prime number. By using the equation p squared is equal to n plus q squared, and let q is equal to 1, 2, 3, and so on and so forth until n minus 1 divided by 2. So, here is our solution. So, same process, our q is, first number is 1. So, since 1 man ato ang q atong pinakauna nga number din hi, so ato siya i-substitute sa ato ang values na to sa equation nga n plus q squared. So, substituting 527, which is our n, plus 1, which is our first number sa q. So, 1 squared. So, 527 plus 1 squared is equal to 528. Since 528 is not a perfect square, so proceed ta. So, we have our q now is 2. So, 527 plus 2 squared, or 2 squared is equal to 4 man, diba? So, 527 plus 4 is equal to 531. Again, 531 is not a perfect square until mabuta sa point nga nakapangita ta og perfect square, and we end up sa ato ang q sa number 7. Okay, so substitute 527 plus 7 squared, or 49. So 527 plus 49 is equal to 576. Since we know that 576 is a perfect square, so mustap po ta diyan dapita. So, the square root of 576 is 24, because 24 squared is 576. Okay, so therefore, our n is 527, is a composite number, and its factors may be calculated. So, we will gonna use the Fermat's method, okay? So, the formula, what is the formula again? So, the formula of Fermat's method is n is equal to q squared minus p squared. So, pila man ato ang p squared? So, 24 squared minus our q squared, which is 7 squared. So, factor, we will gonna factor out 24 minus 7 and 24 plus 7. So, we will gonna calculate each. 24 minus 7 is equal to 17, and 24 plus 7 is equal to 31. So, 17 times 31 is equal to 527. So, our result here is equal to our n, meaning our solution is correct. So, this is the last example that we have. So, we have letter D, factor n is equal to 2,027,651,281. So, the solution here, since dako naman siya dato ang n, no? And then, napo ni siya rule nga ato ang gamiton. Okay, so the first step that we are going to do is to find the square root sa ato ang n. So we have here, since the square root of n is equal to 45,029, so mo na siya square root sa atong n. So the square root of 2,027,651,281. So ang ato ang square root ana, yung square root ana is 45,029. But dili ta mo start sa 45,029. Okay? So we will gonna start our calculations with our m is equal to the next number, which is 45,030. So that would be our m. Okay? So we have this, we have the column sa m, and then naputay column sa m squared minus n. Okay? So first number that we have here is the 45,030. And the first number nga ito makitaan nga na inline sa m squared minus n is 49,619. So na-curious na mo kung asa na to ikuha ang 49,619. Okay? So gikuha na to na by substituting rather to this equation nga kaning m squared minus n. So pila man ang ato ang m dinhi. So kani atong first number sa atong m is 45,030. So we will gonna put squared here. So mahimo na siya 45,030 squared minus our n, which is the 2,027,651,281. So if ato na i-calculate, so mugawas jud ang 49,619. So that is why nganong naatay 49,619 dinhi. So ang next step nga ato ang buhaton is to apply the scheme ni Fermat. Okay, so dinhi sa kilid makita ninyo nga naatay gibutan dinhi sa scheme ni Fermat. So Fermat noted that the method is easier to apply if we use the following scheme. So first we have this one, 2m plus 1. Diba? So muna siya ang 2 gyud kabantay mo na 2 pasunod dinhi. Constant yun na siya kay mauman dinhi sa ato ang scheme. So ang mausobra na to is kaning 1, 3, 5, and so on and so forth. Okay? So let's substitute. So we have 2 plus our m. Our first m here is for 45,030. So 2 times 45,030 plus 1 is equal to 90,061. So nagthink na pud mo nganong naa na po'y 139,680. Okay, so nagthink ba mo? Okay, so ang gibuhat ana is ato rang simply add the 49,619 plus 90,061. So mugawas ang 139,680. So mana na ta sa first scheme na dinhi, di ba? So ato na ta sa second scheme, which is mausog na pud ang last number, which is ang 1, mahimo na po siya 3. Okay? So mga prime numbers ragod siya kay 1, 3, 5, 7, 9, 11 and so on and so forth. Mojo na ang mga prime numbers. Mao po na ito ibutang if di pa ta makakita sa until makakita ta perfect square sa ato ang n. Okay? So padayon ta. So we have here 2 times 45,030 plus 3 is equal to 90,063. So that is our second scheme. So nitulin po ta sa atong m ha. So pasunod na Japon na siya. Okay? So constant ragya po ng 45,030. So next is 2 times 45,030 plus 5 is equal to 90,065. So pareha ragya po ha. So kung nag-think mo nga nung na ay 319,808 gi-add ang 229,743 muna siya na atay 319,808. Okay? So same gyapon kay di pa man siya perfect square, no? Until moabot ta sa point nga makapangita na ta sa ato ang perfect square. So here it is. So ato ang m, ato ang last number din sa ato ang m is 45,041. Okay, sumod mo na tong m. So we have here ni-stop na puta sa ato ang p squared nga 1,040,400. Okay, ni-stop ta diyan dapita. Because ang 1,040,400 is a perfect square na. Okay, so 1,040,400 is equal to 10,202. Okay, so since nakapangita na ta sa perfect square sa ato ang n, which is pila gito atong n? So atong n is 2,027,651,281. So ni-stop na putas sa ato ang q or ato ang m nga 45,041, and then we come up nga ang ato ang q squared dinhi is 1,020 because we find out that 1,000 or 1,040,400 is a perfect square. Okay, so 1,040,400 is equal to 1,020. So to check if sakto ba jud ato ang solution or ato ang calculation nga ginabuhat, we will gonna apply the Fermat's method. Okay, so we have here our n. So n is equal to sa ato ang last number sa ato ang m, which is 45,041, minus sa ato ang p squared, okay, which is 1,020. So factor out 45,041 minus 1,020, and then on the other side we have 45,041 plus 1,020. So we have this answer now. 45,041 minus 1,020 is equal to 44,021. On the other hand, 45,041 plus 1,020 is equal to 46,061. So next step is we will gonna multiply both numbers, okay? So 44,021 times 46,061 is equal to 2,027,651,281, which is ni-equal siya sa ato ang n, meaning sakto ang ato ang solution, sakto ang ato ang process, kay ni-equal man siya at the end. Okay? Okay. So in my conjecture part, or the conjecture or showing the patterns observed, so I have here the theorem. So ang gipasabot ani nga theorem is ang formula nga gigamit ani nga study, which is ang formula ni Fermat or the Fermat's method. So we all know nga ang formula ni Fermat is n is equal to p squared minus q squared, with p minus q is greater than 1. That's why ang ato ang gina-focus dinhi is all odd integer number, and we must put in our minds that our odd integer number or our n will be always greater than 1, because if our n is greater than 1, meaning it is a non-prime, if and only if there are non-negative integers p and q such. Okay? So maura gyud na ang ginapasabot sa theorem or sa conjecture nga being stated dinhi. So in my justification of the conjecture that I have, so I have here the explanation. So di lang nako basahon ha. So ako lang i-summarize. So ang ginapasabot dinhi, gina-explain lang nila katong ako ang examples kanina nga katong naaga ning mga rule gani, like if kinahanglan ta mo pangita og perfect square sa ato ang n, and then mo ni siya kaning sa pinakauna nga phrase kana by using the Fermat method, which is n is equal to p squared minus q squared. So kana gina-factor nato mo nang nana siya ito nga if n can be expressed as the difference of two square of non-negative integers, which is the formula mo na siya difference of two square of non-negative integers, formula na siya ni Fermat. Okay, mo na siya Fermat's method. Okay, and then unsa man natong gibuhat sunod ato, di ba, atong gi-factored out. So mo na siya ang n nato kay ma-factor out into p minus q and p plus q. Okay, so mo na siya. So since p minus q is greater than 1, then p plus q also, and then n is not a prime. Okay, so next is kani siya katong atong gi-divide kani og 2 katong ato ang q is ni stop lang ta sa 11 kay dili ta pwede mo lapaw sa ato ang q, which is atong gi-substitute ang values nato. So for example kato sa ato example kanina, so we have 23. So ni stop ta sa 11, dili na ta kinahanglan mo proceed sa 12 even if wala pa ta kakita sa perfect square, di ba? Wala pa ta kakita perfect square ato. So ni stop ta sa 11 kay dili ta pwede mo lapaw yun. So to check if sakto pa jud akong giingon, atong gi-substitute ang value using this equation nga n minus 1 divided by 2. So mo to siya. So for example 23, so 23 minus 1 is equal to 22 divided by 2 is equal to 11. So that's why ni stop ta sa 11. So dili puot pasabot nga abi di wa pa ta nakapangita sa perfect square sa ato ang n, mupadayon lang gyud ta nga mupadayon until makakita ta sa iyang perfect square. No, it's a big no. We need to follow a rule, and our rule is to use this equation para dili ta mo pasagad og tulin og proceed para makapangita ta sa ato ang perfect square sa ato ang n. Okay, so mao ra ni ginapasabot sa justification sa ako ang conjecture. So the next is katong using scheme, katong larger number na gyud ang ato ang gigamit sa ato example kadto nabot tag 2 billion. So gigamitan nato scheme para mas mapadali nato siya. So that is one way on how do we factor our n by using the Fermat's scheme. Okay, so mo to siya. More na ang ginapasabot sa explanation sa akong justification of the conjecture. So gina-elaborate lang niya tanan dinhi. So muna siya. So the advantage of using the second squares method is that we check smaller numbers to see if they are squares. Okay, so mao to siya.
In the conclusion part, therefore, this study will provide the reader a technique on how to use the Fermat's methods in the easiest and fastest way of factoring a large number.
So in the conclusion part, I said here that this study will provide the reader a technique on how to use the Fermat's method in the easiest and fastest way of factoring a large number. So based on the result that we have, so we can say that if ato ang n is odd integer and ato ang n pod can be factored as n is equal to qp, so meaning 1 is less than or equal to q and then it is less than or equal to p. Okay, then n can be written as a difference of two squares. So motong niana ta ito nga naatay q squared ug naa po tay p squared, because remember the formula ni Fermat or the Fermat's formula is n is the difference of two squares. So if ato nang sulaton, musulat tag n is equal to q squared minus p squared. Muna siyang difference of two squares. Okay? And also, Fermat's factorization technique gives Fermat's factorization technique gives all ways of factoring a non-square odd integer, which is our n is greater than to 0, into two distinct factors. Okay? So if ato pang ma-remember tong example nato nga ato ang ginabuhat kanina, ma-rememberan dyan nato nga naatay duha ka buok distinct factors sa ato ang n. Okay?
So my recommendation of this study, when it comes to factorization of bigger and larger composite integers, there is a possibility that the scheme of Fermat has a limit in using this technique. Moreover, if we go through in this study, there is another method or technique needed for that.
In the recommendation part, so I said that when it comes to factorization of bigger and larger composite integers, there is a possibility that the scheme of Fermat has a limit in using this technique. So moreover, if we go on through this study, there is another method or technique needed for that. In other words, Fermat's method works best when there is a factor near the square root of n. Okay, so due to the limitations of our study, we recommend, or I recommend, that further investigations and thorough analysis if the factors are far from the square root of n.
So yeah, that would be all, and thank you so much for listening. Have a great day ahead, everyone.